Welcome to today's video. We're exploring the role of loss functions in regression and how they help evaluate model performance. Understanding these metrics is crucial for building effective predictive models. Let's get started. Here's the outline for this presentation. First, we'll define what loss functions are and why they're important. Then, we'll explore common loss functions used in regression, such as mean squared error and mean absolute error. Next, we'll learn how to use loss functions to compare models and evaluate their performance. Finally, we'll look at how to compute these regression metrics in Python. By the end, you'll have the tools to assess and improve your regression models. A loss function measures the difference between predicted and observed values. Lower values of the loss function indicate better model performance. Loss functions are used in several stages of the modeling process: training the model, testing its generalization on unseen data, and comparing different models to find the best fit. Common loss functions for regression include mean squared error, root mean squared error, and mean absolute error. Mean squared error, or RMSE, calculates the average of the squared differences between predicted and observed values. Root mean squared error, or RMSE, takes the square root of MSE and has the same units as the target variable. Mean absolute error, or MAE, calculates the average absolute differences between predicted and observed values. Each of these has its own strengths and applications. Loss functions help compare models to find the best fit for your data. For instance, using mean squared error, you can evaluate two regression models to see which one better predicts the observed values. The model with the lower MSE generally performs better and generalizes more effectively. Mean squared error is calculated as the average of squared differences between predictions and observed values, while RMSE is the square root of MSE. These metrics are sensitive to outliers because errors are squared, magnifying large discrepancies. Lower values for both metrics indicate a better fit. Mean absolute error provides the average magnitude of errors in the same unit as the target variable. Unlike MSE, MAE is less sensitive to outliers, making it useful when data contains extreme values. It's a straightforward way to understand how far off predictions are from the observed values. Python makes it easy to compute loss functions using libraries like scikit-learn. For example, you can calculate MSE, RMSE, and MAE for your model by importing the relevant functions and passing in the observed and predicted values. This allows you to quickly evaluate your model's performance and make improvements where needed. To summarize, loss functions are essential for evaluating regression models. Metrics like mean squared error, root mean squared error, and mean absolute error provide insights into model accuracy. Python simplifies the computation of these metrics, making it easier to compare and refine models. Use these tools to ensure your regression models perform effectively and generalize well. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.